I'm going to show the derivation of how we get from here, which I think is a pretty understandable equation, to Gibbs free energy equation, which is easy to plug and chug into if you know what everything means, but what does it mean? How did we get here? What is Gibbs free energy? We'll go over this derivation. I'm never going to ask you to give it back to me, but I think it is important to look at it one time so that you do understand kind of where this comes from. Please do read this key point. I'm sorry if it's annoying you that it is lopsided. It's talking about the delta S, the change in entropy of the surroundings, and that there is actually going to be a relationship that we can draw between that and delta H, which I'll do in a moment. One last thing. See how here there are indicators of universe, system, and surroundings. So this one's pretty important. If you don't see anything as a subscript, it means that it's for the system. So anytime you write delta G, it's always free energy of the system is equal to enthalpy change of the system minus T entropy change of the system. Okay, so these are all SYS, we just didn't write them there. What this little lopsided box is saying is that we can say that the entropy of our surroundings is equal to the opposite of the enthalpy change of the system, right? Because the heat energy is going to flow from the system into the surroundings divided by temperature. Next, we're going to divide the delta G equation by the opposite of temperature. So make sure that you understand how I just got this work, okay? My negative signs canceled out here, my temperature canceled out, and this is just delta S of the system. So at this point, you can see that our negative delta H of the system over T, same thing we have down here. So I can actually replace that term with delta S of the surroundings. So I've replaced it, and remember, just regular delta S means it's delta S of the system. And look what we have here. We have delta S of surroundings plus delta S of system. That equals what we know from up here, that equals the delta S of the universe. You already know from the second law of thermodynamics that the delta H of the universe is always increasing in a spontaneous process. So positive delta S of universe is what we're looking for, except that's really hard to calculate. So instead, we can calculate delta G. And because these have opposite signs, a positive delta S means spontaneity, and a negative delta G is going to mean spontaneity. This equation is much, much simpler than calculating the entropy change of the universe for every process. That gets really complex. So this is a simplification that works. If delta G is negative, you have a spontaneous or thermodynamically favorable reaction. When delta G is positive, it is non-spontaneous in the direction written. It's going to be spontaneous in the opposite direction. And when delta G is 0, your process is at equilibrium.